This is a recording about questions 3 and 4 as shown here. Given a question of this nature, number 3, which appears very straightforward, i.e. calculate the frequency, it is helpful to write out what you know. Thus, to calculate frequency, we will use nu equals c over lambda, which requires c, the speed of light, which is 2.998 times 10 to the 8 meters per second, and lambda from the question, which is 700 nanometers. The point of writing all this out is that we can see straight away that our units don't match up. C has meters, whereas lambda has nanometers. Therefore, we would have to convert one of these units to the other. The simplest way would be to change nanometers to meters. Since nano simply means times 10 to the minus 9, or is equivalent to 10 to the minus 9, then we can say that 1 nanometer is equal to 1 times 10 to the minus 9 meters. And if we have 700 nanometers, then we would simply multiply 1 times 10 to the minus 9 by 700. Thus, these units will cancel, and we'll be left with 700 times 10 to the minus 9 meters, or 7.00 times 10 to the minus 7 meters. It's the same thing, and won't make any difference to our calculation. Now we can simply fill in the values into our equation. So we have nu is equal to 2.998 times 10 to the 8 meters per second, all over 7.00 times 10 to the minus 7 meters. The meters would cancel, and we would be left with 4.28 times 10 to the 14 per second. Since 1 hertz is equivalent to 1 per second, 1 wave per second, then we can also rewrite this as 4.28 times 10 to the 14 hertz. Writing out what we need becomes more relevant in question 2. In question 2, we have to calculate wavelength, but there are several pieces of information provided. So we have 2.35 Tesla, carbon-13 nuclei, and 25.147 megahertz. Since wavelength is found from the same equation as in question 1 by rearranging terms, so we would have lambda is equal to c over nu, we can see that all we will need are the speed of light and the frequency. The 2.35 Tesla and the carbon-13 nuclei are not required for this. It's just extra information. And since hertz is a unit of frequency, we will use that. Once again, we have a situation where the units don't match. Megahertz means mega per second. The per second is fine because we have that in the speed of light, which we'll put up here. It's the same as it was before. Therefore, we have to get rid of the mega part of the megahertz. Mega simply means 1 times 10 to the 6. So 25.147 megahertz is simply 25.147 times 10 to the 6 hertz, or per second. Now we can solve as we did before, by substituting in our terms. I'll rewrite that one so that it's clearer. And we get 11.9 meters, because the per seconds part will cancel. If we then look at a diagram of the electromagnetic spectrum, we see that 11.9 meters falls in the radio wave region. So we've answered question 4.